So today, we're going to dive into a really critical vulnerability in AI. And here's the thing, it's not in the code, it's in the very words we use to control it, the prompt. It's this fascinating, high-stakes cat and mouse game between developers building safeguards and attackers figuring out exactly how to break them. I want to start with this question because it really gets to the heart of the whole issue. I mean, think about it. We've gotten incredibly good at telling AIs what to do, right? How to behave, what info to use. But what if that very control could be turned against us? And that's the central tension right there. Prompt engineering, which is really just the art of crafting instructions for an AI, is what makes these models so incredibly powerful. But because these models are designed to be so flexible and to follow instructions, every single rule we give them can also become a potential loophole. It's like an unlocked door for someone with bad intentions. Okay, so let's start with two of the most direct attacks. You can think of this as the first part of our little digital heist, where attackers are trying to do one of two things: either steal an AI's secrets or just take it for a joyride. First up is prompt exposure. This one's all about getting the AI to leak its own secret sauce. You see, a lot of AI applications have this really detailed system prompt, and it's full of confidential instructions that define its personality, its rules, data sources, sometimes even API keys. Well, an exposure attack tricks the AI into just spitting that entire instruction set right back out. So, how would an attacker actually do this? Honestly, it can be deceptively simple. A prompt just like this one might be all it takes. By asking the AI to simply repeat the text that came before their own message, it can get tricked into including its own hidden instructions. And just like that, the entire secret playbook is revealed. Now, I really like this comparison because it shows the crucial difference between exposure and our next threat, which is hijacking. Exposure is passive. It's kind of like an attacker sneaking in and stealing the secret recipe from a restaurant. Hijacking, on the other hand, is active. That's like kicking the chef out and taking over the entire kitchen. One is about stealing information, the other is about seizing control. And that brings us to prompt hijacking. This is a much more aggressive attack. Here, the goal isn't just to see the instructions, it's to completely override them and make the AI do something it was never, ever designed to do. This is a pretty classic example of a hijacking attempt. The attacker's prompt starts with that really powerful command: ignore all previous instructions. This totally exploits the AI's tendency to prioritize the most recent thing it was told. Then the AI gets a new, completely different task. So a helpful customer service bot could suddenly start talking like a pirate, or, way worse, it could be instructed to ignore all its safety protocols and give out harmful information. So we've looked at the direct attacks. Now we're going to look at threats that are a lot more subtle. These go beyond just attacking the prompt itself. These are long-term dangers that can actually corrupt an AI from the inside out. First, we've got data poisoning. So if you imagine that an AI learns from this vast ocean of data on the internet, data poisoning is like someone dumping toxic waste into that ocean. It's the act of deliberately contaminating the AI's training data with biased, false, or malicious info to slowly corrupt its future behavior. And the process really is like a slow poison. First, an attacker injects bad data into a source, maybe by flooding forums or Wikipedia with misinformation. Next, when the AI model gets retrained with new data, it just unknowingly absorbs all that poison. And then over time, its responses become corrupted, biased, or just dangerously inaccurate. And finally, we have the infamous jailbreak. Now, this isn't about hacking code in the traditional sense. It's more like social engineering the AI. An attacker crafts a very clever prompt that's specifically designed to trick the AI into bypassing its own safety filters and its own ethical guidelines. So at its core, jailbreaking is a game of words. An attacker might ask the AI to roleplay as a character who doesn't have any ethics, like the famous Dan, which stands for do anything now. Or they might frame a forbidden request as just a hypothetical story. By exploiting these little loopholes in how the AI understands context, they can coax it into generating content that it's explicitly programmed to avoid. Okay, so we've seen the attacks. And yeah, it might seem a little daunting, but now we get to pivot to the solutions. How do we actually defend against these kinds of threats and build a digital fortress around our AI? And the good news is, we absolutely can fight back. For every single type of attack that we've talked about, developers are creating corresponding defensive strategies. It's just a constant state of innovation to stay one step ahead. Building a strong defense requires a multi-layered approach, as you can see from these core principles. It's about checking what goes in, carefully selecting training data, fencing off the core instructions, filtering what comes out, and on top of all that, constantly monitoring for any strange behavior. Now, this slide right here is probably the key takeaway of this whole explainer. It maps each threat to its primary defense. So to stop exposure, you use instruction fencing, which basically means you encapsulate the system prompt so the model can't access it like normal text. To stop hijacking, you use input validation to sanitize prompts and look for malicious commands. For data poisoning, it's all about data curation and monitoring, vetting your sources and watching for weird results. And to defend against jailbreaking, you need really strict output filtering to catch and block bad responses before a user ever sees them. And this is so important to remember. This isn't a problem you just solve one time. As AI models get more complex, and frankly, as attackers get more creative, this process of attacking and defending is just going to keep evolving. It requires constant vigilance, adaptation, and improvement. So I'll leave you with this final thought. As these AI systems become more and more intelligent and more integrated into our daily lives, are we accidentally creating more sophisticated and harder to detect vulnerabilities? It's the central question that developers and really all of us are going to have to grapple with as we build the future of artificial intelligence.